Good evening, everyone. Welcome to the McDonald Observatory YouTube live stream. Glad you can join us today. So my name is Saul Rivera. I'm one of the public program specialists here at the McDonald Observatory. I help run the streams like these and also help with our public programs, so guide tours, star parties, special viewing nights, and also help out with the K-12 team every now and then. And today I'm joined by my awesome colleagues, Judy, Jay, Abby, and Joe. And why don't y'all introduce yourselves?
I'm Joe Wheelock. I would do public programs here, run telescope to star parties, guided tours, and everything. And my role tonight, I will be answering questions you might have in the chat. And so after we all start, I'll be kind of going backstage for that part.
I'm Judy Meyer. I'm K-12 program coordinator, and I'm going to be here talking about things we see in the night sky. And I'd like to invite anyone to say hello in the chat wherever you are, Facebook or YouTube or Instagram. We'd like to know where you're from and if this is your first time with us or not. And let's pass it over to Abby.
Hi, I'm Abby McNeil. I work for Judy. I'm part of the K-12 program too. So we work with the public programs with like all of our star parties and tours during the day, but also with field trips and other cool stuff like that. And I'll be also telling you about some stuff in the night sky today.
Hi, I'm Jay. So I'm actually pretty much in the same position as Abby. I also work for Judy. So yes, focus on the education side and doing field trips and outreach and things like that for teachers, especially too. And I also will be telling you about some things in night sky.
Let me just add one thing. Abby and Jay are brand new, so we're just throwing them in, and we're so happy they're here.
Yeah, it's so nice having more people here. Yeah, but yeah, well, thank y'all for joining in, and the colleagues, and for y'all joining in on the live stream. It's really exciting. So we're going to be talking about the constellation of Sagittarius and all the cool things they can see in it. Thankfully, weather is cooperating pretty well so far tonight, so we'll be able to see some really cool live views and learn some cool new info about it. So we currently work and live out here in far west Texas at the McDonald Observatory. We're in the middle of nowhere, so light pollution isn't that big of an issue for us. Dark the sky, some more things you can see. And also, before I forget, as kind of Joe mentioned, he'll be monitoring, answering questions. If you have any questions, feel free to drop it into the chat. Joe will answer them, or if there are a question that requires more detail or will be cool for one of us to answer, it will be sent along to us. And you can see your question on screen. And I see we're getting some from many parts of Texas, such as Springfield. We got one from California, from Georgetown, Oklahoma, Rhode Island. So we got people from all over tonight. So if you're wondering why I look kind of like black and white compared to my colleagues, is because I'm currently located inside one of the domes here at the Visitor Center. So the Visitor Center here pictured has an amphitheater and telescope park that we usually show, well, people usually go through during a public star party program. And telescope I'm in right now is our 16-inch telescope. Well, I'm in the dome, not in the telescope itself. Telescope's not big enough for me to fit in. But this telescope we'll be using for viewing today. So usually when the public comes through, we'll be looking through the eyepiece at different targets. But for tonight, we actually have a camera attached to the telescope that's connected to the computer, that's then connected to the social media platforms. And the camera I'm using right now is a thermal camera. So actually I'm wearing a black shirt right now. And if I look into the camera, it looks like I'm possessed, but that's just how the camera reacts with my eyes. There are no ghosts inside this body, as far as I'm aware. And also, if you have any questions about like the camera specifics or the telescope specifics, they will be in the description of the YouTube channel of our YouTube video. So this video will be saved to our YouTube channel, McDonald Observatory on YouTube, and our Facebook page, just McDonald Observatory on Facebook. Sadly, with Instagram, it won't be saved there, but if you're watching from Instagram, once we watch, come check us out on our YouTube channel. And kind of going to the main subject of the show, tonight we're going to be talking about Sagittarius, which is one of the constellations in the night sky. So Sagittarius is a very big constellation. It's one of the zodiac constellations. So it's mostly known a lot through culture and cultures throughout history. Actually, one of the first references to it was back in the 2nd century by Greek astronomer Ptolemy. There's also a cluster named after him, Ptolemy's cluster. And Sagittarius to many looks like an archer. Some see it as a centaur archer. Some might see just a bow and arrow. But there are actually some asterisms, or what we call a group of patterns associated with Sagittarius that are sometimes easier to find. The big one, Sagittarius, is known as the teapot. So if you connect some of them, you get a little teapot, short and stout, and kind of where the part is where you would pour out water, it almost looks like steam is rising out of it. That steam being the Milky Way itself. This constellation is visible usually during the summer and autumn nights in the Northern Hemisphere and has some cool targets in it, which we'll get into later on tonight. One of the other things I want to point out about Sagittarius, it's near what we call the Milky Way's galactic bulge, its galactic center. So this is a part of the Milky Way that has a large amount of stars, and to us here on Earth, when you can see the Milky Way with the naked eye, like for example here at the McDonald Observatory, you can actually see that it's brighter there. It seems to kind of poke out a little bit. So in this little kind of picture, you can see how we're outlining that center with the Milky Way dust line going through it, and Sagittarius and the constellation of Scorpius are right next to them. So just using this constellation can help you find out where you're looking at. So, hey, it might not be dark enough for the Milky Way, but if you're looking near Sagittarius, you know, hey, I'm looking pretty close to the band of the Milky Way. And for our first target for the night, one of the things that's near the constellation of Sagittarius is the star-forming region known as the Swan Nebula. And I'll pass it over to one of my colleagues to talk more about it.
Okay, so I'm going to talk to y'all about Swan Nebula. So if you can see from this image right here, the Swan Nebula is called actually the Swan Nebula because it does kind of like a swan floating on water. There's also a couple of different names I'm going to tell you all about.
Yeah, and also before you continue, Jay, sorry I forgot to mention, but what I'm showing off right now is actually a live view from the telescope. So this is what the telescope's seeing right now. So if a cloud passes through and it gets very dark, you know the cloud passed through. If you hear a loud noise behind me and the view doesn't work anymore, that means something happened to the telescope. But yeah, continue, Jay.
Okay, so another name, actually the first name for the Swan Nebula was the Omega Nebula, because when it was discovered, it actually looked more like the Omega symbol in the Greek alphabet, but with better telescopes, they were able to see a little bit better, and they actually saw it looks like a swan. So there's about 4 names for the Swan Nebula. So we have the Omega Nebula, Horseshoe Nebula, of course the Swan Nebula, and then also a check mark. And then for some people, it actually does look like a lobster as well. As my counterpart Judy likes to point out sometimes, it looks like a lobster with one of its claws taken off. So it's just a couple of different names, but one of the most common is going to be the Swan Nebula. So this nebula is actually between 5,000 to 6,000 light years away from us. So it is pretty far, but compared to some other objects, it's not as far. This nebula also is about 15 light years in diameter, and it is home to a lot of young stars. So these stars in this nebula are actually just a few million years old compared to like our sun, which is several billion years old. So additionally, in this nebula, the stars, they're very hot, and they're causing the gas in that nebula to actually emit the light that we see that causes the shape for this swan. So it actually is also very massive. It's about 800 times more massive than our sun, the whole nebula. And let's see, I think that's about it. It's very bright and very hot. I think it's a beautiful nebula. And like I said, it looks really like a swan's kind of floating on that beautiful sea of stars.
Yeah, thank you, Jay. Yeah, some other little info about it. So kind of over here is where it's located in the night sky itself. So it's near the, so it's a little bit above the constellation of Sagittarius. So you can say if we were looking at the centaur shape, a little bit above his head. So you can see the swans flying over the archer. And also, I also believe we have really cool images as well from NASA and such. So that's in case if we had bad weather. So you can notice, hey, it looked the same about a week ago. Yeah, so here's some more info about it in case you're wondering, as well as some really cool images from NASA and such. And meanwhile, going to pass over to my colleagues to talk a bit more and maybe a bit more detail about these images while I switch over to our next target really quick, which is also bird themed.
So, as I mentioned, the gas in this nebula is excited from those hot stars. So, if you look at the bottom left image, that's actually an infrared image composite because we can't really see a lot of these different colors with our naked eye. Um, Luckily, we are able to see some of those colors because of that emission. It does cause those colors to show on the visible spectrum. But these colors actually tell us what elements are in this nebula. So as you can see, the red is going to represent sulfur, green is going to represent hydrogen, and the blue is going to represent oxygen. And then in the top right-hand corner, that's actually going to be a more zoomed in picture of a part of that nebula, kind of showing those different colors of the gas that are present from everything that's interacting in that nebula. And the next one's actually going to be Abby.
Yeah, so I'm getting this pointed, Abby. Why don't you tell us some info about the next target?
You got it. So what we're about to be seeing is Messier 11, or the wild duck cluster, and it's named this because of a rough V shape. I don't know if you'll agree that you think it looks like wild ducks, but that is up to the eye of the beholder. The reason they call it that is because the biggest stars in it form a triangle-looking shape, and so to some people looking at that, it looks like wild ducks forming a cluster. You know, that's what they think. It was discovered in 1681 by the astronomer Gottfried Kirch. And then later along in 1764, that's when Charles Messier first cataloged it, where the M11 comes from, Messier 11. So it's been in our eyes for a long time. And hopefully it'll be in our eyes pretty soon with a live view too. This right here, our cluster, has over 2,900 stars in it, which is, it's also an open, oh, perfect, beautiful. It's an open star cluster, and it's one of the biggest open star clusters around. And as you can see, if you're looking for a triangle looking shape or trying to see ducks, I think it's up to your imagination. Judy's imagination, she seems to go, I don't know. I don't know. This one is a little further than Jay's. This one's 6,200 light years away, which, if you put that into miles, is several quadrillion miles away from us, but still closer than a lot of things out there. And this one's also a little younger. This one's approximately 250 million years old. And whenever we get to the next slide, it's going to show us which constellation this is a part of. It's in the Scutum constellation, which is also Latin for shield. So it was supposed to look like a shield whenever we were seeing this constellation. So that's what I got to show you as we're looking at Messier 11.
Awesome, thank you. Someone in the chat on Instagram said it's like got reminded of like the Mighty Ducks flying. They're flying in that V formation.
That is a great movie series, and I agree with you. If you think about them all as little hockey players.
I really think I've seen one movie about it, but that was when I was like 6. I don't remember anything.
You gotta watch them, the rest of them, so it's delightful.
Yeah. Oh, a question has come in, and see, one of y'all want to answer it while I'm getting the next target set up. From Sweet Like a Berry on Instagram. How do we determine the age of a star? Judy,
What
you
a
want to take
good
this one?
question.
Oh, nice.
Do I want to take that? We No, I don't want to take that. I have a really hard time answering that question. So I would like some help. So my brain has gone blank. I'm thinking of other things right now. How do we determine the age of a star? We check its driver's license.
Yeah, so one of the ways we determine the age of the star is by looking at so there are different things. One of the things we can do to determine the age of the star is seeing the mass of it. So we know the more massive the star is, the faster it's going through its material. So more massive stars will be aging faster. Looking at the star's color can give us an idea of where this is in the lifespan. So when stars are born, they're usually like bright blue as time goes on. So here's some other images of the wild duck cluster. You can see these young stars are a nice, vibrant blue color. And so that lets us know they're young, they're very hot, very energetic. And also, like the light can give us the idea of like the energy output, surface temperature. Usually we have lots of little pieces we can get about the star, like can let us give an idea of the star's age. And also, thankfully, a good number of stars are around are similar stars to our sun or smaller, which can help us out. We have lots of references to do that. For more specifics, I currently cannot remember off the top of my head, but it's been like kind of the things that we kind of built upon each other year over year, or basically century over century.
Can I just throw it away to I'm gonna say just spell it KW3 on YouTube. I wish we could just cut it in half and count the rings, because that'd be so much easier.
Cut it in half and count the rings. Yes, that would be easier. So yeah, with a star cluster, it's easier to determine the age because we know that more massive stars don't last very long and less massive stars last longer. And so you just look at your star cluster and see at what mass they cut off. And if you've got more massive ones, then you've got a younger cluster. And if you've got only less massive ones, then you have an old cluster. That part I do know.
Yeah, try to see what remains.
What remains?
Yeah, for the stars.
Yeah.
Also, if you're wondering where the wild duck cluster is located, it's here. So kind of here, as Abby mentioned, it's near Constellation of Scudum, so above Sagittarius. And this thing can actually be visible with the binocular. So actually, not just the wild duck, but also the Swan Nebula, even though I'm going to show next. Several of these targets can be seen with just a pair of binoculars on a nice dark sky. I actually have seen wild duck there with wild duck cluster with a pair of binoculars. Oh, this is a good question from Jason Wendell. The composition still confuses me. I know we can send probes to things close to us, but how do we know the makeup of planets and stars? So the way we do this is through a science called spectroscopy. A lot less painful than it sounds. So spectroscopy is a science of basically using light and rainbows to figure out what's going on in the world around us. So the way one of the instruments we use works, a spectrograph, is let's say we have a rainbow bar, visible light spectrum. We get a lamp filled with hydrogen gas, shine a light through it, then look back at the rainbow bar. You're going to see some black lines, some pieces missing. This is known as hydrogen signature. Every single element, ion, molecule has its own unique signature, its own pattern. So when you get the reading of a star or a galaxy or a planet's atmosphere or a nebula, you basically get your rainbow bar, your visible light spectrum, and it looks like there's all these pieces missing. Looks almost kind of like a barcode pattern. Then you're going to try to play kind of like a puzzle game. You see what fits, what lines up. Oh, hydrogen lines up. That means there's hydrogen here. Helium lines up. That means there's helium, so on and so forth. We can also use this to figure out how hot something in space is. So I mentioned the temperature of stars. We can use it with that. It also plays into the age of stars, what we call their metallicity. Since we know stars are fusing hydrogen to helium, seeing which elements are in the star can let us know where along its lifespan it is. how far away things in space are, and if things in space are moving. And not only if they're moving, but their speed and direction. Yeah. And with that, I actually got ready for our next view. Also, Emily Morinsky says hi to us, Julie. So hi, Emily. Glad you can join in. And now I'm going to go over to our next target, which is one of my personal favorites to see through a telescope, known as the Messier 8, the Lagoon Nebula. So, ooh, that's such a pretty one. I always really like this one. So with this, so the Lagoon Nebula, I really enjoy it. I'd say it's like a 2-for-1 special. So with the Lagoon Nebula, not only are we seeing a star-forming region, which gives you kind of like the lagoon, kind of looks almost like a murky lagoon to me, but you might notice there are several bright stars in here as well, because it's actually kind of like a 2-for-1 thing. We have a star-forming region and some newborn stars. So Messier 8, the Lagoon Nebula, is the star-forming region itself, while the nearby cluster of young stars is known as, let's see, I know I had it written down, as NGC 6530, I believe it is. Aha! I did remember. NGC 6530. So this is just a really cool one. Again, this is actually really bright. You can even see this with the naked eye. It's that bright. If you're like out here on the moonless night, just in the dark sky, you can make this out with your naked eye. It was discovered by Giovanni Hodierna before 1654, and it's about 4,100 light years away. So kind of up to this point, some of you might be wondering, well, what actually is a light year? So light year is how far light can travel in a year, which is about 6 trillion miles. So as the thing being about 4,100 light years away, that's putting this object at about 24 quadrillion miles away from us. So about 15 zeros. So make sure you have your fair movies packed for your trip out here. And nearby open cluster, the NGC 6530, contains about 652 stars and is actually younger than the wild duck cluster. While the duck cluster stars were about 200 million years old, basically making them stellar toddlers, the stars near the Lagoon Nebula are about 4 million years old, basically making them newborn babies. And if you're wondering where this object is located, it's right here. So kind of a little bit about this above the spout of the teapot. So if you're out here kind of viewing the Milky Way and the constellation, you might notice that a little bit above the spout, among the darker kind of cloudy parts of the Milky Way, there seems to be a random bright fuzzy area. Kind of mess with your eyes if it's actually there or not. That is the Lagoon Nebula. And other bright patches you see along the band of the Milky Way were things like the Swan and other cool clusters. And now we're going to get ready to move over to our next target. So, Julia, I'll pass it over to you so you can tell us about what we'll be looking at next.
Okay. Our next target is not a star cluster, but it's sort of a star cluster. And it's not a place where stars are forming. And it's not a thing that's really separate from another thing. It's a piece of the Milky Way that we can see kind of through a window. And it's called the Sagittarius star cloud, the small Sagittarius cloud. And so do I show the picture of it, or do I wait until you get there? I can't decide.
I say go on and show the picture of it, like how it might look like with a big telescope, and
All right.
compare it to our own.
Well, this picture, that's your lagoon. There's your information. All right.
Some of the other cool pictures, like from NASA and Hubble of the lagoon.
There it is. All right. So this picture shows part of the teapot, and then the small Sagittarius star cloud is circled. So it's just above the lid of the teapot. And when we look at that, what we're going to see is a whole lot of stars. And then there's also a couple of dark nebulae that are included in there. And I know we've used that word a lot, nebula, and we haven't really defined it. So let me define it. A nebula is a space cloud. So it's a cloud of gas in space. And a dark nebula is a cloud of gas in space that's not giving off light. And so it blocks the light from things. And so we'll see these dark nebula, maybe one, maybe two of them. One of them's a little easier to see than the other. And I don't know what our live view is going to look like yet. So we'll get there. And then there's also a cluster of stars embedded in the Sagittarius star cloud that we may be able to see. But basically, it's just a whole lot of stars, and some of them look like they're in lines and streaks, so that's kind of fun to look at. The Sagittarius star cloud is big. It's over 300 light years wide, and that is about 1.8 quadrillion miles. So that's a 1, hold on, and an 8 and 14 zeros following it. So that's that many miles, and it's about 10,000 light years from Earth. And I was looking this up because this is something new to me, and I read in one article that it was 100,000 light years from Earth. And I thought,
wow,
that is incorrect, because I know the Milky Way galaxy is 100,000 light years across. So it's not 100,000 light years to the small Sagittarius star cloud. It's 10,000. That article was wrong, and I could use my, critical thinking to think of that. So are you ready to show it to us, Saul?
Yep.
Yay.
Got the live view here.
Take a look. So what you see in the upper part of the view is a star. But what I like to look at is these lines of stars. So there's little lines of stars, especially below that star. They're kind of going down. And our dark nebula, I'm looking for it. I think there's one that's sort of 2/3 of the way from the left to the right across the bottom of our view. And the other one, I don't know. And maybe if we were to stack this image over and over with our camera, we'd get a better idea where that is. But that is our Sagittarius star cloud. And it's just a really, really rich part of the Milky Way galaxy. And lots and lots and lots of stars to see.
Yeah,
So,
I am noticing if you look towards the very bottom, you see kind of some of the really bright stars there seem like there's cloudiness around them.
Yeah, there's an area where there's less stars, and there's no reason it should be, because we're looking towards the center part of the Milky Way. So, yeah. So that is our Sagittarius star cloud, but let me show you another picture of it. And I'm just going to put my slide back in here. So this is a picture from Roberto Colombari, and it's a beautiful, beautiful image. And our star cloud is the whitish part of that, okay? And here you can definitely see the dark nebulae that are there. And then the red thing above is it's a different object whose name I forget. But it's a beautiful, beautiful image, and it shows you just how rich in stars this is. And so that's our Sagittarius star cloud. Now, let me see what I'm supposed to show you next. The next thing I'm supposed to do is talk about the next thing we're going to look at. And the next thing we're going to look at after our Sagittarius star cloud is another nebula. And this is one that we call the Trifid nebula, which almost sounds like a bad guy from science fiction to me. But the Trifid nebula is, Saul was showing you the Lagoon nebula that was two things in one. Well, the Trifid nebula is three. So the Trifid nebula has a nebula, that's a cloud, and it's a cloud where stars are forming. And part of that cloud is reflecting light, and part of that cloud is emitting light, and part of that cloud is dark, so it's blocking light. So it's three kinds of things in one: a star-forming nebula, a reflection nebula, and a dark nebula. So, and you'll see the dark part. Oh, is that ready for me, Saul?
Yep.
Yay! Throw that in. That's beautiful.
Ooh.
So there's our live view of the Trifid nebula. And when clouds of gas condense and collapse, that's where they form stars. So where it looks darker or thicker, that's where we're forming the new stars. And the way to actually see those new stars is to observe a nebula like this by observing infrared light, because infrared light can pass through those clouds. Visible light really can't. So we're seeing the dark clouds here. And I really like how I like the shape of this. And I like that there is this in the upper part of the view here, just above those two bright stars, maybe you can see a piece that kind of looks like a finger hanging down. And that is part of our nebula too. That's part of our star forming region. There's a little jet that happens right there. So it's very interesting. This nebula is about 4,100 light years away from us. So what else was 4,100 light years away? The Lagoon, right? I think that's what you said. And it is a stellar nursery. And some folks kind of don't take too kindly to turning anthropomorphizing. I can't say that word. Anthropomorphizing stars. So some folks call it a stellar factory rather than a nursery. But so we have young stars in there, and the reflection nebula is the cloud that's reflecting light. It looks like a crawfish. Okay.
Ooh, I can kind of see it.
And you can see the dark nebula, and you can see the glowing nebula. So that's our Trifid nebula, and I think that's just quite lovely. Let me show you a really pretty picture of it that comes from, I think, the Hubble. Oh, this is where we find it. And this is M20. And I know, and that's my fancy slide about it. This is not the picture from the Hubble. There it is. There's the picture from the Hubble. And it's a little bit more close up than our last one. And it is upside down from what we saw before. So our little finger of gas of cloudiness is at the bottom of the view instead of the top. But you can definitely see that dark nebula in there. And it's very, very, very beautiful. So that's our Trifid nebula. Now, one of the things that we haven't mentioned yet, and maybe we should have, was why we keep calling things Messier. But for those of you who, I see that we have some people who really know these things in our audience tonight, but Charles Messier was a French astronomer working in the 1700s looking for comets because he was working for the King of France. He kept finding things that weren't comets, and he made himself a list of things not to confuse with comets next time around. So the Trifid Nebula is number 20 on the Messier list. The small Sagittarius cloud was number 24. The Lagoon Nebula was number 8. The Wild Duck Cluster was number 11, and the Swan was number 17. And yeah, so Saul, what do you have for us next?
So what I'm going to try to do is put in one last one that's in the air, another Messier object called Messier 22. Just gotta move around a little bit to find it. So while we're moving that around, let's see, a question from Mr. Borcherding. We'd love to hear about the K-12 opportunities as you go. I'm a physics and astronomy high school teacher in Indiana. Wow. So Judy, Jay, Abby, this feels like y'all's department.
Okay. And since Jay and Abby have been here less than a month, it's probably my department since they haven't done much yet. We do all kinds of things here. We're having school groups come and visit us. We're going out to places, I think, in the near future. And we do offer teacher professional development workshops in the summer, and we're going to do 2 during the school year. The summer ones are 3 nights and kind of parts of 4 days, and we cover all kinds of things. And what we do depends on where the funding comes from for our workshop. What else did I want to say about that? We do lots of things. I hope you can join us sometime. The other thing we do is we do some virtual school visits through an outfit called Connect to Texas. That's the word connect, the number 2, and the word Texas. It's a free platform that connects with schools by Zoom. And you can learn more about that on our website, mcdonaldobservatory.org/learn. And if you have specific questions, you're welcome to email us. And now we know who you are. And we'll even talk to people in Indiana. So.
Yeah, you can come visit for the workshops. And also, just as well, if you just want to do some more online ones, if you don't want to connect to Texas, we have done live streams in the past, our K-12 focus. Even did some activities like building a galaxy. And speaking of building things that have lots of stars, we got our surprise final target for the night. Messier 22, a globular star cluster.
Woo!
Yeah, so this globular type star cluster, so it's a group of about 70,000 stars that are born so close together, they became what we call gravitationally bound. That basically means like their own, basically it's like with them being gravitationally bound, their own gravity is keeping them from drifting apart. It's like if two people held hands, they try running in opposite directions, but in star form. And these stars are stuck this way almost their entire life, making these some of the oldest stars in our galaxy. Messier 22, it's about 12 billion years old, which is a very sharp contrast to the other stars we've been talking about that have been a few million to a few hundreds of millions. And it's located about, let's see, checking my little thing here. 70,000 stars. If I had to guess, it'll be in the tens of thousands of light years away. Weird that it doesn't pop up this is one of the first things to pop on up. Let's see. But this is a very nice cluster. Very, very pretty. And again, it is near the constellation of Sagittarius. So Julie earlier showed the slide that showed the position of the Sagittarius star cloud. And you can see Messier 22 is here as well as the Trifid and the Lagoon Nebula and the Swan Nebula we had just seen before. Let's see. I was trying to show this map here. Let's see. And some questions that came in. Did M22 originate in our galaxy, or is it a transient cluster? So for M22 specifically, not that sure. Most of these clusters are still formed within our own galaxy. So you can see in the early universe, larger clouds of gas, more chances of like this happening. There are some that think that globular clusters were basically dwarf galaxies, little galaxies that orbit our own galaxy that basically got really close to our own. Though from my understanding, most of these globular clusters were still just stars that originate in our own galaxy.
And I hope you can see this. The print is kind of small. Messier 22 is just to the left of the top of the teapot. The Trifid and actually and Lagoon are up and to the right.
Yeah, and actually it is close enough to be seen with the naked eye. And it's only about 10,000 light years away from us. So which is very close for a globular cluster. So yeah, all these targets we got to show off tonight are things just visible in the night sky with the naked eye. As long as you find Sagittarius, got a pair of binoculars, or might not even need a pair of binoculars, just a dark sky, you can see some of this. That's how some astronomers looked in the past. Hey, what's this bright, weird, fuzzy patch in the sky? They point a telescope at it. Let me point a bigger telescope at it, and so on and so forth.
Yeah. There's one more question I see from LP, and that was about the Trifid, and that is, are those protostars forming on the finger? I see two jets that may have stars at the tips, and I think that's probably that. Just like you're probably used to seeing those iconic images of the Eagle Nebula, and we say the stars are forming kind of on the tips of the fingers and the dark clouds. So I'm going to say yes, you're right. Thank you.
A question from Instagram from Brimmer John 14. I heard that M22 has black holes. what would those be? So the idea with some of these globular clusters is they get, as you can see even from the live image, as you're getting closer to the center, it's getting more and more dense. One of the ideas is that the inside will have been so dense, all the stars will have collapsed together into a black hole. So the idea is if there is a black hole in here, it'll be at the very center of it. And there are actually some astronomers have come out here to the McDonald Observatory. I have done research on this. I know there's one that did research on the Messier 13, the Great Hercules Star Cluster, which contains estimates of almost 1 million stars to see if there's a black hole in the center. One of the ways they can see about that is seeing how the stars are behaving as they're getting towards there, because with more stronger gravity, that can change the orbits of the stars. Let's see. Now, let's see if there are any questions. If you have any other questions, feel free to drop them into the chat. This is a good time to ask away. Though there's a question that might be better for you to answer, Joe. One question that came in was, what's the aperture of the camera?
The camera we're using, it is an ASI 1600 camera, if that helps anything. And so it has a pretty small chip size. I forget the exact chip size, but it depends on the size of the telescope, of how large of an area of the sky you would see, and everything. So, yeah, it's a basic answer for that.
Right, thank you. And some other questions that come in. Jason Wendell. So would that mean that black holes are closer to us than we were told? Which I mentioned is like in reference to that the M22 having black hole. Probably does. We're finding out black holes are different. They are actually, some of them can be smaller than we originally thought, and we're trying to go from there. And they might also be closer to us. As long as they don't get close enough their gravity can affect us, we're usually pretty good. And also a question from LP, has the observatory imaged jumbos? So for those that may not know, jumbos is something that was detected by the James Webb Space Telescope, which stands for Jupiter Mass Binary Objects. As far as I know, the McDonald Observatory has not imaged any of them. Maybe there might have been some astronomers trying to follow up and looking into those clouds to detect them, but not any that I know of. But hey, if they have, we might see a paper in it about it in the future. Let's see if there's been any other questions that come in. Let's see, I'm checking over the Instagram side as well. Don't really see any other questions. Oh, there we are. From LP, are jumbos visible only in the infrared? I honestly don't know. I don't know enough about the subject. I assume so, since they're observed in Orion. So you need something really powerful like infrared to pierce through the clouds. Let's see. Ooh. Julie J. Abby, any of the questions y'all want to answer?
Abby, answer this one.
Well, apparently how you clean the mirrors in the telescopes depends on who you ask. But for the most part, it seems to be that the answer is we use dry ice snow to clean them, mostly for dusting purposes. But we also went to the mirror lab yesterday, and it seems like there's some other ways you can clean it too, including horsehair shampoo.
We work with what we can.
Yep.
A question from Kim Lehman. Is this a view of the sky right now? Sadly, it is not. There is a pretty nice clear sky. We can see the Milky Way. Actually, I think by the time I step out, the moon will be rising. But you can see the Milky Way pretty nicely. We'll say, though, whenever you see the Milky Way with the naked eye, you don't usually see like the pinks and the purples and the yellows from long exposure images. Usually what you would see with the naked eye are more like blues and grays. It almost looks like a string of milky clouds.
Yeah. And then the other question we got was, Why are stars white and a blue tint? And Nicholas, why are the live stars that we're showing you white and blue? Because we're using a black and white camera, and so it's a black and white view. Some stars do appear more red, and some more yellow, and some more blue, and some, take all those colors and add them together, and they appear white. So stars appear different colors, but on average, they're kind of white. Anybody have anything to add to that?
No, not really. Depending on the star's age, you might see different colors.
Yeah.
Let's see. So I believe that might be it for the questions. I
Yeah,
don't see.
Let me just add one thing to Kim here about seeing the Milky Way looking like this. It looks like this, especially when you could take a really long exposure photograph. And that's something your eye can't do. So that's why our pictures are so good.
Find one from Jason Wendell. I know it's a little closer to us, but when was the last full moon?
Monday.
Yeah. Monday before that, let's see, pulling up the lunar calendar.
Monday minus a month.
Yeah. Before Monday, last full moon was on July 21st.
Okay, so the new question from Mr. Borcherding is for Saul and Joe. Are most of the images you take with the telescope in narrowband, or do you also do broadband?
That's more of a Joe question. For I know the images we're seeing with visible light, with long exposure, more details with that.
The ones that were used for the live streams, that's broadband.
Okay.
And I think we have some narrowband filters we can use. But narrowband imaging is best suited for areas with more light pollution. So we have a little light pollution here. So we can get by with a lot of good images with broadband.
Nice, thank you. I've seen one question. I think this might be a nice question to end on from Sabrina NT from Instagram. How long have each of y'all been studying the stars? So I might as well start since I read that one. I did 4 years at UT Austin, do have a degree in astronomy. Originally was planning to do research, but came out here as a summer intern as an undergrad. Really enjoyed it, so I came around back. Thankfully, Judy, Joe, and the others still liked me enough to let me come back as a full-time employee. But I've been out here, so basically, I'd say 4 years of more formal studying, and I've been out here on site for 5 years now, and I've learned a lot more as I've been out here from colleagues and other people that visit, and just what happens in the space news.
Mm-hmm. And Joe, how long have you been studying astronomy?
I've been into astronomy since I was 5 years old.
And you're older than 5 now.
A little bit.
You've been here at McDonald since when?
Since 1999.
Okay, so 25 years.
Going on that, yes.
Yeah.
Basically.
Yeah. So Joe is our longest person here on the program tonight, and I've been here since 2002, so I'm the second longest. And Saul's been here for 5 years. Jay, Abby, you want to jump in?
I mean, Jay and I have been here for 3 weeks almost, so we are basically professionals at this point.
You're trained to run the telescope, so
yeah,
that's good.
Yeah. Oh, and I also know, Jay, I know you did some studies with astronomy before coming out here.
Yes, I have my master's, not in astronomy, but in space studies, and not really studying stars, but I was able to teach stars a little bit to middle schoolers for about 10 years too, so that was fun. And teaching helps you learn a lot.
Mm-hmm.
Thank you. All right, so I believe that's about it. Thank y'all so much for those of you joining the program. I do see some people on the Instagram side are just now joining in. Sadly, we have reached kind of the end of the stream, but do not worry. This stream will be saved to our YouTube channel, McDonald Observatory on YouTube, and also on Facebook, just McDonald Observatory on Facebook. So you can rewatch the stream through there. We will be trying to do these type of live streams. We try to do them monthly, so we are planning to do one next month for the moon. So keep your eyes on that one. That'll be a fun one to do. Also, feel free to follow us on social media, just McDonald Observatory on Facebook, Instagram, Twitter, Facebook. If you really enjoyed the stream, leave likes and comments. That helps with the engagement, help us know what people liked and what we can work on, and keep on doing more of what people liked. Also, you can come out and visit us. We have a visitor center, so the general public can come and visit us. So actually, all 5 of us here on the stream tonight are visitor center employees. So, hey, you might have a tour with one of us running it, if depending on when you visit. And we do public programs such as guide tours to our research telescopes, live viewing through the sun if weather cooperates. Also, the more popular one, public star party programs, so people can come out here and look through telescopes like the one I was using tonight. Won't be as much quality as what you saw here on the stream, just because these are very long exposure images, but you can still see some of these with your own eye. And also, we do have a gift shop as well, and also stardate.org. A lot of people have heard of the observatory through Stardate, so check it out through there. And you can check out the other streams on our YouTube channel. We've done over 60 live streams so far, and other media content such as behind-the-scenes look of the Hobby Yearly telescope cleaning process, and also some shorts actually about Sagittarius and the globular star cluster. So we are planning to do more of those. So if you are interested, come and visit us online or in person. And hope you have a good night.